Okay, good morning, students. Today we are going to be looking at our kind of brief introduction to Chapter 12 here. Not going to push too hard this week on that. We've got some other things that we're focused on, but we wanted to get you the basics. A quick review on some vocab. As we look at something being dissolved, we call that a solute. And the thing that's doing the dissolving, that's the solvent. For us, most of the time, the solvent is water, and that makes it kind of nice, easy to keep track of. Not always the case, but just general terms there. As we combine a solute and a solvent, we call that a solution. That's something that we've heard of before, and a solution is also known as a homogeneous mixture. So that's some review vocab for you. And then finally, as we look at the amount of a substance in a given quantity of mixture or solution, we call that the concentration. And these are all, again, terminology that we're going to be using in this chapter here. Concentration can range from really low, which we call dilute, to high, which we could potentially call saturated. And then there's some terminology you might have heard before called supersaturated, and that's something that we may get into, we may not, but just a heads up there. So again, solute, solvent, solution, concentration, be able to use these terms throughout your work. Okay. And then on to taking a look at molarity and how we're going to use those equations. Molarity is more or less what we're going to be looking for in terms of concentration. There's a couple different equations that we're going to use. Molarity's symbol is big capital letter M, and that's going to be moles over liters. Now, the important thing here is that this is moles of solute and liters of solvent. So it's a concentration of moles of solute, liters of solvent. The unit then will be grams per mole. Let me go back here. It is going to be moles per liter, which we could just label as capital letter M. Another equation that's going to be quite useful, potentially, it's good to know. Since we're solving for moles, that's our grams divided by molar mass over the volume. And so that, again, would just break down into capital letter M. But probably the most useful equation that we're going to use is going to be grams is the concentration or molarity times volume times the molar mass. And with this, we can divide out and isolate variables as we need to. I tend to find myself working from this equation because it kind of keeps all my variables in order. But like I said, we're going to take a look at each one individually. Be very particular with your units. Make sure if it's grams of what, and all those different things. We want to have all those components there. Don't forget you can pause this as you need to and review what was written. So we're going to take a look at an example here, and we're going to continue to use our guess method. I'm trying to figure out why this. Oh, there we go. Okay, so we're going to continue to use the guess method, and so we're going to set up our letters here. And so this is one of our examples, and this is a type of problem that you might expect to see. So what is the molarity of potassium chloride solution that has a volume of 400 milliliters and contains 85.0 grams of KCl? So our grams of solute, 85.0, pretty self-explanatory there. Our volume was given to us in milliliters. Now, we're going to want to be careful because with this material, we need to be in liters. So you don't have to show that conversion, but you just divide by 1,000. And let's see what else we have here. How we know that this is the KCl is the solute. It says, what is the molarity of potassium chloride solution? So the solution part tells us that we're dealing with a molarity calculation, but the potassium chloride out in front tells us that it is being dissolved. Our unknown is capital letter M. So we're trying to find that molarity. The equation that we're going to use, we're going to go right into that very basic equation that kind of sums everything up. And hopefully that will kind of make things simple for us. Notice it does have mm, so we do need to make sure that we have that molar mass there as well. And that molar mass is of the KCl. And as we go to our periodic table, we add it up, 74.55 grams per mole. So that's going to be important for us to know. As we go to solve, what we need to keep in mind is that we're solving for molarity. So we need to divide over volume times molar mass so that we can cancel. So our final equation is going to be big capital letter M is grams over volume times molar mass. Make sure you're getting these multiplied together on the bottom before you divide. Your final answer then, to correct number of significant figures, 2.85 times 10 to 0, and then our units and labels both need to be included there. So very easy calculation, I think. Your equation here, G equals M times V times molar mass, is going to be quite useful. So we'll take a look at another example here. This is kind of first way, second way that we're going to look at it. The first way is example number 2, using that same equation. I lost my pen here. Using that same equation that we just used. And so we'll set up our guess method once again. We're given a volume. How many grams of sodium hydroxide are needed to prepare a 250 milliliter solution? 250 milliliter of a 0.5 molar solution. So again, we're seeing this molar term. So chances are we're doing a molarity calculation. So 250. Boy, the struggle is real. Again, must be in liters, divided by 1,000. Notice our decimal point here, making that 0 a significant figure. Keep that in mind. We're given a molarity of 0.500. And we're going to go ahead, just because we know that sodium hydroxide on the back of your periodic table, Na+1, OH -1. Formula for that, we're going to note the molar mass as well, just because there's a decent chance that we end up using it. Our unknown is grams, so if I were setting up lab material for you and I have to prepare this solution for you, which we do pretty regularly in chemistry, I would just calculate out this exact calculation. I want to make 250 milliliters of a 0.5 molar solution. This is the exact calculation that I would use. So again, nothing really fancy to change here. Grams would be equal to the 0.500 molar solution times 0.50 liters for volume, and then the molar mass. So enter those in your calculator, keep track of your sig figs. So the grams of solute that is required would be 5.00 times 10 to the 0 grams of NaOH. So when I measure this out on the balance, that's what I would be looking to obtain. So again, pause this and watch it again if you need to. Little bit of chemical naming up here once again, so make sure that you're keeping track of that as well. There's another way that you can do this, and I think that this isn't necessarily a better way. It's not a worse way. It's just another way. And for those of you that are looking to kind of continue up the ladder in chemistry, you're going to want to be able to think through these different steps. Like I said, I think if the last way worked for you, go for it. But for those of you that are really kind of pushing your way through chemistry, it'd be very helpful for you to know this. So instead of setting this up in the guess method, I'm going to kind of give you a step 1, step 2 ways that you can follow this. So the first step that you're going to want to kind of get to is go to moles. And the reason why is because we're going to kind of set up a dimensional analysis type problem. Now, our general equation is molarity is N solute over liters of solution. And with this information, we can get ourselves 2 moles by just plugging in the values that we're given. Biggest mistake that we see, students not converting volume to liters, so make sure that you do that. As we isolate liters, as we isolate moles, we're going to multiply those 2 values together, and we're going to get a value of 0.125 moles of sodium hydroxide. Now, what we can do with this is do a moles to grams. So the second step for this particular type of problem that you may wish to do is a dimensional analysis. And as you know, or as I mentioned before, this isn't better, it's not worse, it's just a different way. And so if we take our moles, 0.125 mole NaOH, and then we'll set up our conversion factor, and we're going to grams. So as we know, this grams per mole is going to come from the periodic table. And after entering that in your calculator, we would end up with that same value, 5.00 times 10 to the 0 grams of NaOH. That ends up working out, and like I said, you could do this way, or you could use that G equals M times V times molar mass equation. So it's kind of really your choice on that. As we continue to move through, we're going to be taking a look at work a little bit more, but I just wanted to kind of give you that option as well. You're going to have a student example for you to do, so go ahead and try that out, and then you can check it against the teacher version. The answer is in parentheses there at the end. So if you have any questions, please reach out to your teacher, and good luck.